So here we're looking at question 6 of exam 2 from the NHT 2018 exams. Okay, so we've got time series data plotted below from 2011 to 2001 to 2012. It's time, but we've scaled that. Instead of saying 2001 here, we've got 1, and instead of, down the bottom, that's going to be 2012, we've got 12 instead. So in your calculator, where it's got, you end up having year number, that would be 1, 2, 3, up to 12, whatever the number happens to be, and that will correspond to a particular year value. Now, what we've got here, so we've scaled that, and at the moment, this is the sort of plot you would get. Okay, so you think that's your X and that's your Y, because time is always in time series, the year to time is always on the X. So the relationship between the power and U value is clearly not linear. This is definitely not linear. Okay, so what we're going to do is a log 10 transformation to apply to this variable power to linearize the data. Okay, so that means you need to put in your calculator, have a log power thing here, and you're going to log it and then fill it down. Now, I've actually prepared that earlier. So I've got the year, I've got 1 to 12, power, I've got all the power, relevant power things. I've also got the log value. So basically all I've had to do here is, as you can see, this is if you can see, where am I? Down the bottom, that's the formula I've got. So in that log power column, I've gone log 10 of the power, and it fills it down for me. Okay. Oops, I don't want to do that. I want to escape out of that. Escape out of that. Okay. And that's where you got all the data. The data's filled out based on that information. Okay, so let's go back to the question for a moment. So the question says, apply this transformation to the data to determine the equation of the least squares line that can be used to predict log 10 power from the year number. So we want to write down the intercept and slope of this least squares regression in the appropriate boxes. So this is, remember, this is essentially y equals a plus b x in terms of the way, the convention wise. Okay, so we need to do, and we're going to do that, importantly, it's in 4 significant figures. All right, so we go back to here. So I've then plotted that. Oops, got plotted that here. And as you can see, this is my A, 4.2869, but I want 4 significant figures. So I'm only looking at the 4.28, and I round it 4.287. Okay, so it's going to be 4.287. And in the next one, we're looking at, oops, we're going to go 0.0. They're not counted in terms of our significant figures. So I go 990, and I round that up to 1 to 2, so it's 0.09902. Okay. Oops. Okay, so that means I'm going to be 0.09902, and that's your answer for that question. Okay, so you've filled that out, and you've done it into 4 significant figures. Okay, now in part A, you've got to predict the power in megawatts expected to be generated by the wind in 2020. 2020 here is an important point because we don't have a scaled number for 2020. So 2020, so what would that number be? You just count down, and what it ends up being is 20. Okay, and it's 20 that we use in the year number spot. Okay, when we do this part, we're going to use the year number of 20, not 2020. We're going to use 20 because that's what we've been using. Okay, now the question here is given it in terms of log 10 of power. Okay, and there's a few ways you can do it. My suggestion is use solve, and I am going to show you over here in your calculator. You type solve, put bracket, log 10 of x. So x is what we're after. X is our time. You could use whatever letter you want there, but that's what we're after. Equals, we fill it out. You notice I put here, this is the time value I put. Okay, comma x, and we get a value of this value here. So, and if you look back at the question, we've got to zoom back out again. Oops, sorry about that. And we want it to the nearest 1,000 megawatts. So what that means is I've got 185. I'm just going to 1850972. So we've basically got to go to the nearest 1,000, which is basically here. Okay, so it's going to be 1851000. Okay, so I would write solve. So I'd write solve out, get your thing, and then your answer is going to be 1851000 megawatts. Okay, and that's how you'd answer and finish off that question. Okay.